Welcome to 3DOptix tutorials. Today we are going to review coordinate systems in 3DOptix. First we need to create a new file. I pre-populated this file so we can just move into the project. Okay, when we start an optical design in 3DOptix, we are going to need to align the components we place in the 3D layout. Dragging and dropping is fine in the beginning, but we will eventually need to align them all to a common optical axis. To do this, we will turn to the coordinate system feature. By default, the global coordinate system located at the center of the breadboard is the reference coordinate system for all components. Let's start by grabbing a few optics and mounts and putting them into the 3D layout. We'll start with the outliner bar and we'll grab a user-defined light source and also a rectangular detector. Now we'll go to the optics catalog by right-clicking, opening the optics menu, and we'll select a 1-inch lens. So we'll sort by lenses and we'll look for a 1-inch lens, which is 25.4 millimeters. We'll just grab the first lens in the list here. Okay, great. Now we're going to do the same thing for a 2-inch lens. Sort by lenses. Put in 50.8 millimeters for a 2-inch lens, and we'll grab the first lens in the list. All right, great. Now let's zoom into the 2-inch lens really quick, and let's look at its local coordinate system. If you click on any object, the local coordinate system will pop up wherever it lies on that object. For lenses, it will be on the front surface, whether that's curved or flat. And if we go to the outliner bar, we can see that. So if we click on local coordinate system, it will deselect the lens, and the local coordinate system will stay up. Okay, so let's back out a little bit or zoom out a little bit. And let's add a 1 and a 2-inch lens mount to our optical system. Go over to the outliner bar, go to the catalog, and we'll search in the mounts filter dropdown. We'll look for 2-inch mount. There's one, a KM200 is a 2-inch mount, and a KS1R is a 1-inch mount. We'll drag these guys and drop them into the optical system. Okay, perfect. Okay, now the first thing we are going to do is mount the lenses inside the mounts using the reference coordinate system option. So we will select first the 1-inch mount. We'll go up to the ribbon bar where it says Move Rotate, and we'll select that. Now with the Move Rotate option, the moving and the rotating are all done with reference to whatever coordinate system the lens is referenced to. Obviously, by default, this is the global coordinate system, but we can choose another. Now, the order of operations here does not matter. So we can move a lens, we go 80, and then rotate a lens, or rotate and then move, it does not matter. Okay, so what we're going to do is select a reference coordinate system. This is a 1-inch lens, so we're going to select the 1-inch mount. So we'll expand the mount out, and we'll click on the coordinate system. Okay, and by seeing this dotted line, we can see that the 1-inch lens is now referenced to the mount. So we're going to put it at the origin. That's going to be inside the mount properly placed. Now let's back this out a little bit so we can see the lens. Okay, great. Maybe in a little bit more. Perfect. Now let's do the same thing for the 2-inch lens. Click, go to the Move Rotate, select Reference Coordinate System, and in the outliner bar, we'll go to the 2-inch mount, and we'll select its coordinate system. And again, we get the dotted lines to the reference. Put this at the origin of the mount, and back it out a little bit so we can see where the lens is. Perfect. Okay, now that we have our lens set in the mounts, let's make sure our optical system is now well aligned. We'll choose the 2-inch mount and set its reference coordinate system to the 1-inch mount. Select the 2-inch mount, go to the Move Rotate, select Reference Coordinate System. We'll choose the 1-inch mount. Okay, and now we will set it behind the 1-inch mount. Perfect. Let's go a little bit farther. Okay, great. And again, the dotted line shows you where the reference is. Okay, so let's now put the light source at the origin. We will reference the detector to the light source. Click Select Reference CS again, and we'll go to LS1, which is our light source, and we will put this 300 millimeters behind. Maybe a little bit farther. Let's try 500. Perfect. Okay, let's go back to the first mount, and let's reference this to our light source as well. Outliner, click on Local Coordinate System, and set this to the origin. Maybe 200 millimeters away from the light source. Okay, perfect. Now we have a well-aligned optical system. And if we grab our light source, we can move all objects at once. And this is really nice for alignment. That way we don't have to move every object individually. Okay, let's put the light source back at the origin. Okay, great. Okay, and now that everything is referenced to a coordinate system, one easy way to see what is referenced to which is we can go to the top taskbar and hit the Show Links line. Now what this is going to do, it will show all the references from each object. So the detector is referenced to the light source is referenced to the global coordinate system, and as you can see, Mount 2 is referenced to Mount 1, and Mount 1 is referenced to the light source here. And since we know what is referenced, we can also use this as a measuring tool. So let's grab the lenses and pull them out really quick. Now, if we wanted to measure the distance between the two lenses, we could simply reference one of the lenses to the other. So let's reference the second lens to the first. Okay. And as you can see, the front face of each lens is where the local coordinate system is, and that's where your measure points are. So in this configuration, if we wanted to know the distance between the two lenses, we would simply need to tell in the ribbon bar how far away to place the objects, and then subtract out the thickness of the first lens. Because as you can see, the local coordinate system starts from the front of the lens. So the distance between the two lenses would be the separation we specify minus the thickness of this first lens. Okay, let's undo everything we just did and put the lenses back in the mount. Okay, and now our lenses are back inside their respective mounts. Now, to measure CAD distances is a bit more difficult because the local coordinate system for a CAD object is going to be at the center bottom of the base. Okay, and lastly, we can add our own custom coordinate system into the 3D layout. This is a great way to segregate portions of your optical system if you have multiple sub-assemblies or folding mirror paths. We just need to right-click in the 3D layout, and halfway down the list, we can add coordinate system. Okay, it looks like it did set it over there. It must have been our view was canted, so decided to put a little bit closer to our mount here. Now in the outliner bar, this object will be called CS for coordinate system. And the coordinate system, just like any other object in 3DOptix, can be deleted by either using the outliner bar, ribbon bar, we can right click on it and select remove, and also left click on it and hit delete on our keyboard. It goes away. All right, let's bring this back. Now we can also drag and drop our coordinate system anywhere we want to in the 3D layout, similar to all objects in 3DOptix. And we are not limited on how many coordinate system objects we can place. So we can continue to add as many as we want. Okay, let's get rid of a couple of these. All right. Okay, and like most objects, we probably want this in reference to something else, such as the global coordinate system or another object or detector or light source in our optical system. So if we click on this and go up to the ribbon bar, like all of other objects, we can move and rotate as needed. The relative position here, let's do 300. Okay, and we can also select a reference coordinate system for this. We select the KM200, it will now be referenced to this mount. All right, coordinate systems are very important to setting up your optical system, and I hope this makes it easier to work with them in 3D optics.